I am A. Anand, Rogni College of Engineering and Technology, Department of Civil Engineering, C8602, Structural Analysis 2. Here I am discussing about two hinged arches, analysis of two hinged arches. Two hinged arches. Arches are curved structural member used to support heavy loads on large spans. When the load is imposed on an arc, it remains primarily under compression, thus it receives lower bending moments. As the name indicates, a two-hinged arch is an arc hinged on its two supports. Also, it is a statically determined structure since the horizontal thrust cannot be calculated by equilibrium conditions or equations. So this is the figure two-hinged arch per unit length. Reaction locus is a line that gives the intersection point of two reactions for a particular position of loads. Next, methods of analysis of two hinged arches. First one is strain energy principle method, or first theorem Castiglione's theorem. And next, consistent deformation method or unit load method. And next, internal stress resultant induced in arch section. There is two types, normal thrust and radial shear. So here, next, rib shortening in the case of arches. In a two-hinged arches, normal thrust, which is a compressive force along the axis of the arch, which shortening the rib of the arc. This is turn will release part of horizontal thrust. Normally, this effect is not considered in the analysis in the case of two-hinged arches. Depending upon the importance of the work, we can either take into account or omit the effect of rib shortening. This will be done by considering or omitting strain energy due to axial compression along with the strain energy due to bending in evaluating heights. And next, analysis of two-hinged arch. A typical two-hinged arch is shown in figure. In case of two-hinged arch, we have four unknown reactions, but there are only three equations of equilibrium available. Hence, the degree of statically determinacy is 1 for two-hinged arch. This is the diagram, two-hinged arch of a circle. Okay. And this, the fourth equation is written considering deformation of the arch. The unknown adherent reaction is calculated by nothing that the horizontal displacement of hinges HB at B is 0. In general, the horizontal reaction in the two hinged arches is evaluated by straightforward applications of the theorem of least work. And next, there is an example problem of two hinged arches. The problem is a parabolic arch hinged at ends has a span of 60 meter and a rise of 12 meter. A concentrated load of 8 kN act at 15 meter from the left hinge. The second moment of area varies the second of the inclination of arch axis. Calculate the horizontal thrust and the reaction at the hinges. Also calculate the net bending moment of the tension section. So this is the two hinged arch diagram. So total span is 60 meter and the central height is 12 meter. At the two ends, you are having the horizontal tension force and the vertical reactions. So you want to find the bending moment, maximum bending moment at 8 kN at the half quarter span section. So in that two sides under the load left of you want to take the x distance and the right of x distance you want to find the bending moment. Here first you want to find the vertical reaction VA and VB. So VB into 60 minus 8 into 15 is equal to 0. VB is equal to 2 kN. Total load VA plus VB. VA is equal to total load minus VB is equal to 8 minus 2, that is equal to 6 kN. Next, horizontal thrust H is equal to integral of 0 to 1 mu y dx divided by O integral of 0 to 1 y square dx. So you are applying this, y is equal to 4x divided by L square x into L minus x. So you are getting the solutions by step. You are getting the equations, that is 0.64 x cube divided by 3 minus 0.0213 into x square 4 by 4 plus 1.76 into 10 power minus 4 into x power 4 divided by 5 into the upper limit 60. So here the mu1 final value will be va x square minus 8 into x minus 115 is equal to minus 2x plus 120. Integral of 0 to 15 mu1 y dx. So I will be applying this. I want to take the limit 0 to 15, 6 into 0.8x minus 0.0133 x square dx. You are getting the final value 4400. And next, limit 15 to 60 mu 2y dx is equal to 15 integral limits 0 to 60, 15 to 60 into 120 minus 2x 0.8 minus 0.013 x square dx. 15 integral 0 to 15 to 60, you are getting the values. The final value is 21330.9. And next you want to find the heights. For that also, that's 0 to 1 integral mu y dx divided by 0 to 1 integral of y square dx. While you are applying this, you are getting the value h is equal to 5.79 kilonewton. And finally the reactions Ra is equal to root of h square plus Va square, getting the answer 8.18 kilonewton. And next Rb is equal to root of h square plus Vb square, getting the answer. The final answer will be mx is equal to 6 into 15 minus 5.79 into 9 is equal to maximum moment is 39.87 kilonewton meter. So this is the final moment. Thank you.